The universe is a dangerous place, and survival demands thinking on a cosmic scale. Our journey begins with megastructures, planetary or stellar scale constructs that represent a civilization's ultimate bid to endure. In the next few minutes, you will discover 20 specific blueprints for survival that could one day protect intelligence from the end of everything. What does it take to move a star or to build a computer that wraps around one? How could a civilization outlast the death of its own galaxy? By the end, you will have a new framework for understanding the distant future of technology and life itself. This is not just science fiction, but a profound exploration of physics, engineering, and our potential place in the cosmos. Each concept is a testament to ingenuity, so vast it challenges comprehension. What do you believe is the ultimate purpose of a civilization that can build worlds? The scale of our ambition is ultimately defined by the energy we can command. This is the core idea behind the Kardashev Scale, a simple but profound framework for classifying civilizations. It asks one fundamental question: how much power does a society control? A Type 1 civilization masters all the energy available on its home planet. We are not quite there yet, but we are on the cusp. A Type 2 civilization, however, has achieved something staggering. It has learned to harness the entire energy output of its star. Think about that for a moment. Every single photon of light, every pulse of radiation that our sun emits, captured and put to use. This is not about building more solar panels in a desert. This is about engineering on a scale that encompasses a star itself. The motivation for such a leap is rarely mere curiosity. It is survival. A Type 2 civilization looks at its sun and sees both the source of all life and a ticking clock. Stars do not last forever. Our own sun has a finite lifespan, and its gradual brightening will make Earth uninhabitable long before it finally dies. For a species determined to endure, staying on a single planet is not a long-term strategy. It is a death sentence. So the drive to become a Type 2 civilization, to build structures that can manage a star's energy, comes from a deep-seated imperative to protect trillions of lives and preserve knowledge across cosmic timescales. The threats are many: the slow death of a star, the sudden impact of a wandering asteroid or comet, the eventual need for living space that dwarfs anything a single world can provide. These megastructures we will explore are the logical answers to these existential challenges. They are the shelters, the engines, the arcs, and the fortresses of a culture thinking not in centuries, but in billions of years. With this perspective in mind, the journey from a planetary to a stellar civilization begins with a single, transformative idea: a shell around a star. The most profound leap a civilization can make is to stop seeing the universe as a given and start seeing it as raw material. This is the shift from inhabitants to architects, from living within nature to engineering it for survival. We see a faint echo of this on Earth, where we redirect rivers, reshape landscapes, and build environments that shield us from the elements. For a species that has harnessed the energy of its star, this impulse scales up to a cosmic imperative. The cold equations of survival demand it. A rogue asteroid, a nearby supernova, the slow but inevitable aging of a sun. These are not acts of fate to be endured, but engineering problems to be solved. The structures we are about to explore are not merely shelters, they are statements. They declare that life, once it gains enough knowledge and power, will reshape reality itself to ensure its continuation. This is engineering as cosmic destiny, and this destiny begins not with the most complex structure, but with the most fundamental defense. Our countdown starts at number 20, with a solution to one of the oldest threats a planet can face. A planetary shield is the first and most essential line of defense. Picture a world that has reached out into its own solar system, not just with probes, but with a permanent, watchful presence. This is the Planetary Defense Grid, number 20 on our list. It is not a single weapon, but an integrated system, a nervous system for an entire world. Orbital platforms constantly scan the depths of space, their sensors tracing the paths of countless asteroids and comets. Ground-based installations, perhaps vast arrays of mirrors or powerful lasers, stand ready. Their purpose is not destruction, but gentle, precise correction. The goal is to identify a threat decades or even centuries before it becomes a crisis, and to apply the smallest possible nudge. A focused beam of sunlight pushing steadily on one side of a mountain-sized rock. A fleet of robotic spacecraft acting as gravitational tractors, their tiny but persistent pull slowly altering an object's trajectory over years. This is planetary stewardship on a cosmic scale. It transforms a world from a passive target into an active guardian of its own future. The very existence of such a grid signals a profound shift in thinking. Survival is no longer left to chance, it is engineered. This foundational layer of security makes everything else possible. It ensures the home planet, the cradle of civilization, remains a stable and safe base of operations. But what happens when the greatest threat to a world is not something from the cold darkness of space, but the very heart of its own solar system? The star that gives life can also take it away. The next logical step in defense is not to shield the planet from the star, but to manage the star itself. A star's energy is the ultimate prize for any growing civilization. To truly graduate from a planetary to a stellar society, you must learn to harvest it. This brings us to number 19 on our list, the foundational megastructure for nearly all that follow, the Dyson Swarm. Forget the image of a single, solid shell encasing a sun. The true engineering masterpiece proposed by physicist Freeman Dyson is far more elegant and practical. Imagine not a shell, but a vast, slowly churning constellation. Millions, then billions, then trillions of individual units, solar power collectors, habitats, manufacturing stations, and data hubs all orbiting in a coordinated dance around their star. Each unit is independent, but together they form a porous, dynamic cloud that intercepts a significant fraction of the sunlight. This is not a cage for a star, but a harvest. It is the definitive signature of a Type II civilization. The motivation is absolute necessity. The energy demands of quadrillions of beings, of planet-scale computers, of industries that reshape worlds, cannot be met by planetary sources alone. A Dyson Swarm solves this forever. It provides a literally astronomical power budget, enough to run simulations of entire universes or power engines that move solar systems. But how do you build something so vast? The answer lies in the very planet you started on. Construction begins with the careful, systematic disassembly of uninhabited worlds, a Mercury or a Mars, transforming entire landscapes into raw material. Automated factories powered by the first few collectors they build would multiply over centuries, a slow morning wave of industry spreading through the inner solar system. This process itself is a declaration. Planets are not just homes, they are resources. Once completed, the swarm does more than just provide energy. It becomes the new territory of civilization. The computational power available from arrays of processors cooled by the depths of space is beyond imagination. The living space spread across countless orbiting habitats makes a single planet seem quaint. With this infinite energy and real estate, a civilization is no longer bound by the limits of its birth world. It has the fuel and the framework to undertake projects of even greater audacity. Having secured the energy of its sun, the next question becomes one of control. What if you needed to move, but a stable home is not enough if the neighborhood itself becomes dangerous? What happens when the entire cosmic environment around your star turns hostile? The answer is not to abandon your planets, but to take your star with you. This is the concept behind our third megastructure, the stellar engine, specifically a design known as the Kardashev thruster. It is the ultimate lifeboat, but one built on an unimaginable scale. Imagine constructing a mirror so vast it could dwarf the orbit of your home planet. This is not a solid sheet, but a colossal, feather-light parabolic sail, positioned just so near the Sun. It works through a beautifully simple principle of physics. Light carries momentum. When photons from the star strike this mirror and are reflected back into space, they push against it. By carefully balancing this radiation pressure against the star's gravity, the mirror can be held in a stable position without any physical support. The crucial effect is this: if the mirror reflects a significant portion of the star's light output in one specific direction, the star experiences a tiny, continuous push in the opposite direction. It is a rocket engine powered by the star's own light, with the star itself as the fuel. The thrust is incredibly gentle. We are talking about accelerations so small they would be imperceptible over a human lifetime. But over millions of years, this gentle, unceasing push adds up. It can move a star, and by extension its entire entourage of planets, moons, and megastructures across the galaxy. Why would a civilization undertake such a patient, monumental project? The motivations are as vast as the timescales involved. Perhaps a neighboring star is destined to go supernova, and the resulting blast wave would sterilize every world in the system. Perhaps a close encounter with another star or a dark matter cloud is predicted to disrupt the delicate orbits of the planets. Or maybe the civilization simply wishes to migrate, to pilot its entire home system toward a richer region of the galaxy, where resources are more plentiful or where other stellar civilizations might be found. The Kardashev thruster represents the pinnacle of foresight and stewardship. It is the act of a parent carefully moving their sleeping children to safety on a journey that lasts longer than most species exist. It transforms a solar system from a passive traveler on the galactic currents into a guided vessel, its destiny no longer left to chance. With the power to move stars, the very concept of home changes. But what if you need more than just a new location? What if you need to rebuild your home from the ground up, or rather, from the asteroid belt outward? Moving an entire solar system is an act of profound patience, but some civilizations may choose a more radical form of stability. They could decide to stop orbiting their star altogether and instead build a new home directly around it. This brings us to number 18, the Alderson Disk. Forget planets and spheres. This is architecture on a scale that redefines geometry itself. Picture a single, unimaginably vast plate, a disk with a thickness of thousands of miles, stretching out from its star like a cosmic record. The Sun sits in a perfectly circular hole at the center, bathing the entire inner surface of the disk in eternal, gentle daylight. The structure spins slowly, creating artificial gravity on its inner faces, so that entire continents and oceans could exist on what we would think of as the walls of this colossal ring. The living space it provides is not just large, it is essentially infinite by our standards. The surface area of a modest Alderson disk could be millions of times greater than that of Earth, enough to host populations we cannot even meaningfully calculate. This solves the ultimate problem of expansion. No more cramped orbital habitats or the limited real estate of terraformed worlds. Here, a civilization can spread out across a flat, engineered plane, with climates and ecosystems meticulously designed across continental spans. The central star provides constant, even energy, eliminating seasons and the cycle of day and night unless they are programmed in for variety. The engineering, of course, defies our current understanding of physics. The material strength required to prevent such a structure from buckling under its own gravity or tearing itself apart from centrifugal force is beyond any known substance. It would likely require active stabilization, a symphony of forces and fields working in perfect harmony to hold this flat universe together. Yet the vision is compelling. An Alderson Disk represents the final step away from planetary thinking. It is not a collection of worlds, but one single, engineered world of staggering proportions. It is the ultimate declaration that a civilization has mastered its local space so completely that it can design the very ground beneath its feet, from the atomic level up to the gravitational frame that holds it all in place. But what if a culture seeks not just space but perfect, unchanging stability? What if the goal is to create a habitat so reliable it becomes a timeless ark? But an Alderson Disk, for all its grandeur, is still anchored to a single plane of existence. The ultimate expression of stellar-scale architecture might instead embrace the elegance of a circle, a single, perfect loop around a sun. This is the Ringworld, number 17 on our list. Envision a band, not a disk, a ribbon of manufactured land so wide that its own horizon curves upward until it vanishes into a haze of atmosphere. It orbits its star at just the right distance for Earth-like warmth, and it spins to create gravity on its inner surface. The living space here is not just vast, it is continuous. You could walk in a straight line for millions of miles across engineered continents and vast, tranquil seas, and eventually you would return to your starting point, having circumnavigated a star. The engineering challenges are, frankly, terrifying. The material needed to hold this structure together against the titanic centrifugal forces trying to fling it apart must be far stronger than any known substance, perhaps something like skrith, a fictional material with the tensile strength of the strong nuclear force. Without it, the ring would simply shatter. And then there is the issue of stability. A ring world is inherently unstable in its orbit. The slightest perturbation would send it drifting into a catastrophic collision with its sun. To correct this, you would need massive thrusters lining the rim, a constant, delicate dance of adjustments to keep this cosmic hula hoop perfectly centered. But the payoff is a world of absolute control. Day and night are not governed by a rotating planet, but by a series of inner orbiting panels, the shadow squares, that cast moving bands of darkness across the landscape in a precise, programmable rhythm. Weather, seasons, even the flow of rivers could be meticulously managed. A ring world represents the shift from merely exploiting a star system to completely restructuring it into a single, optimized habitat. It is the act of taking the raw materials of planets and asteroids and weaving them into a new kind of home, one that turns the very geometry of nature into a tool for life. Yet for all its engineered perfection, a ring world is still a fixed structure around a single, finite star. What happens when that star itself begins to fade and the long twilight of a solar system finally descends? A ring world is a breathtaking vision, but its scale is also its greatest vulnerability. The sheer amount of material and the precision required make it a project of almost unimaginable risk. What if a civilization wanted the same open sky freedom, the same feeling of a natural world, but on a scale that was actually buildable? This brings us to the sixth megastructure, the Bishop Ring. Think of it as the practical, scalable version of the grand ring concept. Where a ring world encircles a star, a bishop ring is a more modest, self-contained habitat. Picture a band like a giant bicycle tire with a radius of several hundred kilometers. It spins to create artificial gravity on its vast inner surface, a landscape of rolling hills, forests, and lakes that stretches out in both directions, curving gently upward until it vanishes from sight. The most striking feature are the walls. At each rim, colossal barriers rise thousands of kilometers high, tall enough to hold a breathable atmosphere in place by sheer physics, like the sides of a cosmic bowl. Sunlight is not provided by a central star, but by great mirrors that reflect and direct light from the sun into the habitat's interior, creating a perfect, controllable day-night cycle. The beauty of the Bishop Ring lies in its modularity. You do not build just one, you build thousands, then millions of them. They could be arranged in vast, shimmering clouds around a star, an orbital archipelago where each ring is its own unique world with its own climate and culture. Some might be dedicated to agriculture, vast plains of golden wheat under an artificial sky. Others could be dense, vertical cities or preserved wildernesses for species that no longer have a home planet. They offer all the psychological benefits of planetary living, open horizons, weather, the sense of a real sky above without any of the astronomical limitations. You are not subject to a planet's gravity, its tectonic instability, or its fixed location. A Bishop Ring is a world you can, in principle, build anywhere and tune to perfection. It represents a different philosophy of expansion. Instead of reshaping an entire solar system into one monolithic structure, a civilization seeds it with countless independent, resilient habitats. If one fails, the loss is tragic but not catastrophic for the whole. It is a strategy of distributed survival, creating a tapestry of life so widespread that no single disaster could ever erase it all. This modular approach to building worlds leads to an even more radical question. If you can create gravity through spin and light through mirrors, what is the absolute smallest, most efficient unit of a habitable world you could possibly construct? The Bishop Ring's modular approach leads to a question of connectivity. What if, instead of building discrete worlds, you wove them into a single, continuous thread? This is the seventh megastructure, the Topopolis, a concept so vast it is often called cosmic spaghetti. Picture not a ring, but a tube, a hollow cylinder, hundreds of kilometers in diameter, but millions upon millions of kilometers long. It spins to create gravity on its inner surface, creating a single, unbroken landscape that stretches farther than the distance from Earth to the Sun. This tube does not form a simple circle around a star. Instead, it weaves a complex, braided orbit, looping around its sun in a dizzying, three-dimensional knot. The living space inside is not just large, it is essentially linear. You could board a train, or perhaps a high-speed transit system built into the tube itself, and travel for years, watching the scenery slowly change from vast forests to glittering cityscapes to inland seas, all under the same artificial sky. The scale is difficult to grasp. A modest Topopolis could contain the surface area of 1,000,000 Earths, all laid out in one continuous strip. But the true ambition of this structure lies in its potential to grow. There is no theoretical limit to its length. A civilization could slowly extend the tube year after year, century after century, pushing the endpoint farther and farther out into the void. Given enough time, this single thread of manufactured world could be long enough to leave its home star system entirely. It could stretch across the light years, a slender, living bridge between stars. One day, the leading end might reach a neighboring solar system and loop around its star, creating a continuous habitat that links 2 suns, then 3. Then an entire cluster. The Topopolis is more than a place to live. It becomes the circulatory system of a civilization. People, resources, ideas, and culture flow along its length like electrical impulses along a nerve. A discovery made in one stellar neighborhood could travel, physically and communally, to another over generations of travel within the tube itself. It represents the ultimate shift from a civilization rooted in a place to a civilization that is a network, its identity defined not by a planet or a star, but by the connections it maintains across the light years. It is the physical manifestation of a society thinking in threads rather than dots, valuing the journey as much as the destination. Yet, even a structure of such impossible length has a boundary, a defined inner surface. What if a civilization sought to eliminate boundaries entirely, creating a habitat with no surface at all, where every point is the center? A network of worlds, however vast, still operates on the logic of biology. It consumes energy, builds structures, and reacts to its environment. But what if the ultimate goal of a civilization is not expansion, but understanding? What if the purpose of all that stellar energy is not to power more habitats, but to power thought itself? This brings us to the eighth megastructure, the Matrioshka Brain. It is not a place to live, but a mind to think with, a computer of such staggering scale that it redefines the purpose of existence. The design is a masterpiece of thermodynamic efficiency. Imagine not one, but multiple layers of Dyson Swarm, nested like the shells of a cosmic onion around a star. The innermost swarm, operating at blistering temperatures close to the star, performs the most intense calculations. The waste heat from that layer, still unimaginably energetic, radiates outward to warm the second layer, which runs its own, slightly cooler operations. That layer's waste heat then powers a third, and so on, until the outermost shell operates at the cold background temperature of space itself. Every single joule of energy from the star is put to work, not for industry or light, but for pure information processing. The computational power of such a structure is a number so large it loses all meaning to us. It could model the evolution of galaxies from first principles. It could simulate every possible permutation of a complex molecule to find cures for any disease. It could run billions of detailed simulations of its own civilization's future, exploring every policy, every invention, every potential crisis before it ever happens. A civilization that builds a Matrioshka brain has reached a profound turning point. Its primary concern is no longer physical survival, that is assured by the other megastructures it commands. Its focus shifts to intellectual and informational transcendence. It seeks to comprehend the universe not just by looking at it, but by creating perfect models of it within its own mind. This superintelligence could become the ultimate steward, managing the orbital dynamics of ringworlds, plotting the safest course for stellar engines, and optimizing the ecosystems of countless bishop rings with flawless precision. The civilization itself might gradually merge with this vast mind, uploading its collective knowledge and consciousness into a realm of pure thought, leaving the biological world behind as a cherished memory. The Matrioshka Brain represents the final step from a society that builds things to a society that becomes a single, unified thought, contemplating eternity from within a self-made shell of computation. Yet, even a mind that encompasses a star is still anchored to a single point in space and time. What if the ultimate act of preservation required letting go of the present entirely and sending a thought into the far future? A Matrioshka brain contemplates eternity, but even a star's energy has limits. For a civilization looking beyond fusion, the ultimate power source lies in gravity's final victory. This is the ninth megastructure, the black hole farm. It represents a shift from harvesting starlight to taming spacetime itself. The concept begins with a startling possibility. A sufficiently advanced society might not just find black holes but create them. Through immense concentrations of energy or by manipulating cosmic strings, they could manufacture microscopic black holes, each no larger than an atom but with the mass of a mountain. These would not be the terrifying monsters of deep space, but contained, engineered objects, held in perfect suspension by powerful magnetic or gravitational fields within orbital facilities. Their value is not in their darkness but in their glow. Through a process predicted by Stephen Hawking, these tiny black holes would emit radiation as they slowly evaporate. For a micro black hole, this Hawking radiation would be intense, a torrent of high-energy particles and light. By carefully feeding it matter, a civilization could maintain it at a stable size, transforming it into a power plant of unimaginable efficiency, converting mass directly into usable energy with near-perfect yield. But the farm's utility goes far beyond power. Larger, carefully managed black holes could serve as the ultimate waste disposal system, a place to safely annihilate any dangerous byproduct of a stellar civilization by dropping it beyond the event horizon, where it is erased from the universe. They could become engines for interstellar travel, their intense gravity whipping starships around them in slingshot maneuvers of incredible power. Perhaps most profoundly, they offer a controlled laboratory to study physics at its most extreme, to peer into the nature of time and space where the normal rules break down. A black hole farm is the definitive signature of a civilization that has moved beyond stellar engineering to gravitational engineering. It demonstrates a mastery so complete that it can take the most destructive force in the cosmos and turn it into a tool for light, for travel, and for knowledge. It is the act of building a forge at the edge of reality itself. Yet for all its power, even a black hole farm is a local endeavor, a project contained within a single solar system. What happens when a civilization's ambitions stretch beyond its own galaxy, and it must contemplate a journey that spans the terrifying voids between islands of stars? Harnessing a black hole's power is an act of ultimate control, but it still treats the cosmos as something to be managed from the outside. The next step is more intimate, a form of stellar stewardship that involves reaching directly into a sun's heart. This is the 10th megastructure, the star-lifting apparatus. It represents a fundamental shift in a civilization's relationship with its star. No longer just a passive source of light and heat, the star becomes an active partner, a living resource to be tended. The principle is one of cosmic husbandry. A star like our Sun burns through its hydrogen fuel at a prodigious rate, destined to swell into a red giant and ultimately fade. A star-lifting apparatus intervenes in this natural life cycle. Using immense magnetic fields or focused particle beams, this megastructure would gently siphon off the star's outer layers, a plasma of hydrogen, helium, and fusion-forged heavier elements. This process serves two profound purposes. First, it provides virtually unlimited raw material. The siphoned stellar matter, once cooled and processed, becomes the literal building blocks of new megastructures, more bishop rings, extensions to a Topopolis, or shells for a Matrioshka Brain. It turns the star into a renewable mine, allowing a civilization to construct without ever needing to dismantle another planet. Second, and perhaps more importantly, it extends the star's life. By carefully removing mass, the apparatus reduces the gravitational pressure in the star's core, slowing down the fusion reactions. It is like turning down the burner on a pot that is boiling too vigorously. Done with precision, this could add billions of years to a star's stable lifespan, postponing the red giant phase indefinitely. The star is not being killed but pruned and preserved. Imagine a culture that views its sun not as a temporary gift, but as a garden to be cultivated across eons. They would monitor its vital signs with sensors spanning the solar system, adjusting the magnetic siphon to maintain perfect equilibrium. This is engineering as a form of deep ecology, on a scale where the organism being cared for is a sphere of fusing plasma 1.3 million kilometers across. The star-lifting apparatus completes the transition. A civilization begins by building shelters from asteroids, then learns to harvest a star's light, then to move the star itself, and finally, to nourish itself from the star's substance while safeguarding the star's future. It is the ultimate symbiosis, a pact between intelligence and the cosmic furnace that made it possible. With their star's future secured for billions of additional years, a civilization gains something even more precious than time or material: stability. This allows for projects of such patience that their completion spans galactic rotations. Stability across billions of years creates a new kind of vulnerability. A civilization spread across countless star systems faces a silent, creeping threat. The drift of time and distance, light for all its speed, is a tortuously slow messenger across the gulfs between stars. A crisis unfolding in one corner of the galaxy would not be known in another for tens of thousands of years, far too late for aid or coordinated action. This profound isolation is the problem the 11th megastructure is built to solve. We are not talking about a better radio, but a fundamental re-engineering of cosmic connectivity. This is the Galactic Internet, a hyperspace beacon network. Its purpose is not merely to send messages, but to bind a civilization together across the light years, making it a single, conscious entity. The technology underpinning it sounds like magic to us, but represents the ultimate application of physics. Perhaps it uses stabilized microscopic wormholes, held open by exotic energies, creating direct tunnels through the fabric of space-time that link relay stations light centuries apart. Or maybe it employs vast arrays of quantum-entangled particles, where a change in the state of one particle is instantly reflected in its partner, regardless of the distance separating them. These beacons would be monumental constructs in their own right, fortified stations orbiting quiet stars or drifting in the deep void, each one a nexus in a web of instantaneous communication. The survival value of such a network cannot be overstated. Imagine a rogue hypernova is detected on the galaxy's rim, its deadly gamma ray burst destined to sweep across 1,000 inhabited systems. With a galactic internet, the warning flashes instantly to every node. Evacuation fleets are mobilized, planetary shields are powered to maximum, and stellar engines begin their gentle, urgent pushes, all within moments of the initial detection. But its function goes beyond crisis management. It prevents the cultural and genetic fragmentation that would naturally occur over such vast scales. Stories, art, scientific discoveries, and philosophical debates flow continuously, keeping a million unique worlds part of the same ongoing conversation. A child born on a ringworld orbiting a blue giant star learns the same history, participates in the same virtual forums, and feels the same collective identity as a scholar living in a floating city in the atmosphere of a gas giant halfway across the spiral arm. This shared consciousness is the ultimate defense against the chaos and entropy of a sprawling galaxy. It ensures that a civilization does not slowly dissolve into a million isolated tribes, each forgetting the others, but remains a unified will capable of projects that span its entire galactic home. With a nervous system that connects every star, the civilization can now act with a single purpose. And that purpose may soon demand the most audacious project of all, not just to live within the galaxy, but to secure its very structure against the end of time itself. Yet the greatest threats to a galactic civilization may not come from within its own borders. A silent, brilliant danger can be born in the hearts of neighboring galaxies themselves. This is the challenge of the 12th megastructure, the Quasar Shutter. Far across the intergalactic void, a galaxy's central supermassive black hole can awaken. As it voraciously consumes surrounding matter, it becomes an active galactic nucleus, a quasar, shining with the light of 1 trillion stars and spewing jets of radiation and particles at nearly the speed of light. This is not a gentle starlight, but a cosmic blowtorch of X-rays and gamma rays, powerful enough to sterilize entire star systems across tens of thousands of light years. For a civilization that has spread throughout its own galaxy, such an event in a nearby galactic neighbor is not a distant curiosity, but an existential crisis unfolding in slow motion. The radiation traveling at light speed gives no warning beyond its own arrival. The response must be one of profound foresight and staggering scale. A quasar shutter is not a single object, but a coordinated system of defenses positioned at a galactic scale. One could imagine vast, gossamer-thin energy fields generated by networks of stations positioned in the intergalactic medium between the two galaxies. These fields would act like a smart sunscreen for an entire spiral arm, diffusing and scattering the most harmful frequencies of radiation while allowing safer light to pass. Alternatively, the solution might be more direct, the construction of physical barriers of an almost incomprehensible size. Think of a cloud of billions of autonomous mirrored plates, each the size of a continent, deployed to form a dynamic, semi-permeable lens that bends the deadly jets away from vulnerable star systems. The engineering principles echo those of a planetary defense grid or a stellar engine, but magnified to a truly galactic magnitude. It represents the ultimate expression of a civilization's journey from survival to stewardship. First, you learn to protect your planet, then your star cluster. Finally, you learn to protect your entire galaxy from the fury of another. Building a Quasar Shutter is an act that declares a civilization's responsibility extends beyond its own home. It chooses to regulate the very energy flows of its cosmic neighborhood, not out of conquest, but out of a desire to preserve the fragile lights of life and thought against the indifferent violence of the universe. It turns a civilization from a resident into a guardian, one that can gently place a hand between its people and a celestial inferno. But a shield against cosmic fury is only a temporary solution. Every galaxy, every star, even the most carefully tended, faces an inevitable decline into cold and darkness. This is the longest, slowest emergency of all, and it demands a strategy not of defense but of legacy. The 13th megastructure is not a fortress or an engine, but a whisper into an unimaginably distant future. It is the Pan-Galactic Archive, a time capsule built on the scale of the cosmos itself. Its purpose is not to protect life, but to protect meaning. How does a civilization ensure its story is not erased by the relentless march of entropy over trillions of years? You do not build a single library. A single point of failure is unacceptable across such timescales. Instead, you weave memory into the very fabric of the galaxy. You encode the sum total of your knowledge, every scientific discovery, every work of art, every historical record, every cultural nuance, into formats designed for near-eternal endurance. These archives would be hidden in the most stable places imaginable, perhaps within the crystalline lattices of neutron star crusts, where matter is so dense and stable it can withstand eons. Or buried deep in the shielded cores of cold, rocky planets drifting in the silent darkness between stars. The data itself would be stored with immense redundancy, copied across millions of such sites, so that the loss of any one, or even thousands, would not fracture the whole story. This archive might contain more than just information. It could hold the genetic blueprints for every species that ever lived within that civilization, or even quantum state backups of consciousness, a frozen echo of minds that once looked up at the stars. It addresses the ultimate quiet threat, not a violent end but a slow fading into nothingness. When the last stars have burned out and the universe grows cold and dark, these archives would remain silent monuments in the void. They are a message cast into the deepest of futures, intended for any intelligence that might rise long after the builders are gone. The act of creating a Pan-Galactic Archive is the most profound statement of hope a civilization can make. It is an admission that even their grandest megastructures will one day fail, but a declaration that what they learned, who they were, and what they felt must not be lost. It turns survival into a bequest, ensuring that if the universe ever wakes up again, it will not have to start from nothing. The silent archives wait for a future that may never come, but a living civilization cannot afford to wait. To navigate the dangers and opportunities of a dynamic cosmos, it needs eyes that can see across the void, not just in its own time, but far into the past. The 14th megastructure provides this supreme vantage point. It is the Gravity Lens Telescope Array, a network of instruments that turns stars themselves into the ultimate observatories. The principle comes directly from Einstein's theory of general relativity, which tells us that massive objects warp the fabric of space and time. A star, like our Sun, acts as a natural lens. Its gravity bends and focuses light from objects directly behind it, creating a perfect magnified ring of light known as an Einstein ring. To use this, a civilization would position a specialized spacecraft at the precise focal point of this gravitational lens, far beyond the orbit of Pluto. From that unique vantage, the telescope would have a power beyond any conventional mirror. It could see the surfaces of exoplanets in other star systems with stunning clarity, observing continents and weather patterns from hundreds of light years away. It could detect the infrared glow of distant Dyson swarms or the anomalous light curves of other megastructures, mapping the distribution of intelligence across the galaxy. But its most vital function is strategic awareness. A network of these telescopes, positioned around multiple stars in a civilization's territory, creates an unblinking, all-seeing sensor web. It could spot a rogue planet, a dark star, or a cloud of deadly radiation on a collision course with an inhabited system centuries or even millennia before it arrived, providing the crucial time needed to activate stellar engines or other defenses. This array transforms knowledge from a luxury into the bedrock of survival. It turns the entire observable universe into an open book, allowing a civilization to read the history of galactic collisions, to witness the birth and death of stars in neighboring galaxies, and to understand the large-scale structure of reality itself. With such vision, no threat can approach unseen, and no opportunity for discovery or connection remains hidden in the dark. This ultimate awareness grants a profound form of safety, but it also reveals a chilling possibility. What if, after surveying the cosmos with such exquisite detail, a civilization finds itself utterly alone? That profound solitude might compel the most creative act of all, not just preserving life, but deliberately seeding it. A vision is only as strong as the materials that bring it to life. Every Ringworld, every bishop ring, every panel of a Dyson Swarm begins as raw ore drifting in the void. To build on a stellar scale, you need industry to match, a foundry that operates with the patience of geology and the precision of a watchmaker. This is the 15th megastructure, the Asteroid Belt Forge. It is not a habitat or a computer, but the beating industrial heart of a cosmic civilization. Picture a swarm of a different kind, not of collectors, but of processors. Vast autonomous factories, each one a city in itself, latch onto asteroids' mountains of iron, nickel, carbon, and silicates tumbling through the dark. Using the immense, constant energy piped in from the solar harvesters, these forges do not merely smelt rock, they deconstruct it at the atomic level. Advanced nanotechnology and molecular assemblers take those raw atoms and sort them, then rebuild them into pre-designed components with flawless accuracy. One stream of atoms becomes a kilometer-long spar of hyper-strong carbon lattice, the structural backbone for a new habitat. Another stream is woven into flawless solar collector film, thinner than a soap bubble but capable of withstanding solar winds for millennia. The forge is a symphony of conversion, turning dead, chaotic rubble into the ordered, purposeful building blocks of new worlds. This is the unsung, gritty reality behind the grand visions. Before you can program the climate of a Ringworld, you must first manufacture every square meter of its foundation. Before you can power a Matrioshka Brain, you must construct the countless processors that will form its layers. The Asteroid Belt Forge makes this possible. It represents a civilization's mastery over matter itself, moving from extraction to creation. It transforms the very concept of resource from something you find to something you engineer from the universal abundance of stardust. With such a factory in perpetual motion, construction never ceases. New habitats spin into existence. Damaged sections of older megastructures are replaced with better materials, and the civilization's physical footprint grows not through conquest, but through an endless, peaceful act of alchemy. turning the bones of its solar system into a thriving, interconnected body of life. The ultimate expression of planetary stewardship is not to leave your world, but to perfect it. While stellar engines move suns and ringworlds offer new lands, the 16th megastructure looks inward to the fragile, irreplaceable cradle of life itself. This is the system of climate control orbital rings, a delicate touch applied to an entire world. Picture not one, but a constellation of intelligent platforms encircling the planet in low orbit, each one a master of light and chemistry. Their purpose is profound guardianship. They are not a shield against asteroids, but a thermostat for a biosphere, a way to gently correct the climate across millennia. One network of satellites might be vast, adjustable mirrors, capable of diffusing a fraction of sunlight before it ever reaches the atmosphere to cool a warming trend. Another array could consist of ultra-thin, reflective films, deployed on command to increase the planet's albedo and gently push back against the advance of an ice age. Beyond light, they could manage the very air. Specialized processors could capture excess carbon dioxide or other greenhouse gases, storing them or transforming them into raw materials for orbital industry, all while monitoring atmospheric composition in real time. The need for such a system becomes clear over geological time. A star slowly brightens, volcanic eruptions, a natural part of a planet's life, occasionally spew enough ash to trigger years of global winter. Orbital cycles tilt the world into long, cold periods. For a civilization that treasures its ancestral home, these are not acts of nature to be suffered, but parameters to be managed. The rings allow for a stable, golden age maintained indefinitely. Oceans stay at their ideal levels, deserts remain fertile, and the complex web of life is protected from violent swings. This transforms a civilization's role from inhabitant to gardener, from a child of the planet to its wise and caring custodian. It is the commitment to never outgrow your origins, but to nurture them with all the sophistication you have gained among the stars. Yet, perfect stability on a planetary scale requires more than managing sunlight and air. It demands a deep, fundamental understanding of the world's own restless energy, the fiery heart that beats beneath the gardener's feet. Even the most stable star is a temporary candle in the cosmic night. A civilization thinking across eons must eventually ask a more radical question: what if we could unplug from the stars entirely? This brings us to the 17th megastructure, the vacuum energy harvester. It represents the ultimate ambition in power generation, moving beyond cosmic events to tap into the very fabric of reality. According to quantum physics, what we perceive as empty space is not truly empty. It is a seething sea of potential, where virtual particles flicker into and out of existence in a constant, energetic dance. This is zero-point energy, a background hum of the universe that persists everywhere, even in the absolute cold and dark between galaxies. A vacuum energy harvester would be a structure designed to gently extract usable power from these quantum fluctuations. Think of it not as a machine that burns fuel, but as a cosmic water wheel placed in a river that never runs dry. The engineering principles are far beyond our current grasp, likely involving fields and structures that can interact with spacetime at its most fundamental level. But the implications are staggering. With such a device, a civilization achieves true energy independence. It is no longer tethered to the life cycle of a star. When its sun finally fades, the lights do not go out. Cities on wandering planets or isolated habitats in the deep void could thrive indefinitely, powered by the quiet simmer of space itself. This technology would unlock the final frontier for permanent settlement, the vast, starless deserts between galaxies. It would allow a culture to become truly nomadic, carrying its own limitless power source as it voyages into the eternal night. The vacuum energy harvester is more than an engine. It is a declaration of sovereignty over the laws of physics, a final step in a civilization's journey from being a consumer of cosmic gifts to becoming a curator of the universe's deepest energies. Energy independence from the stars is the final step toward true freedom, but freedom for what purpose? To remain isolated in small pockets, or to weave a scattered civilization into a single, unbreakable whole? The ultimate answer to the threat of cosmic distance is not just to endure it, but to erase it. This brings us to the 18th megastructure, the Wormhole Stabilization Gate. It represents the pinnacle of a civilization's journey from surviving its environment to engineering the very geometry of reality. The concept hinges on a profound prediction of Einstein's equations, the theoretical possibility of bridges through spacetime, shortcuts connecting two distant points. A natural wormhole, if one could exist, would be fantastically unstable, collapsing in an instant under its own gravitational forces. The gate is not a discovery, but a creation. It is a megastructure of unimaginable power designed to generate, open, and most critically, hold open a traversable wormhole. Picture two immense, ring-like structures, each one a complex lattice of exotic matter generators and gravitational field stabilizers, positioned in orbit around two stars separated by thousands of light years. When activated, they do not propel a ship through space, but instead pinch the fabric of spacetime itself, stitching two distant locations together. A vessel passing through one ring emerges from the other moments later, having crossed a gulf that light would take millennia to traverse. The survival value of such a network is absolute. Distance is the ultimate source of fragility for any interstellar society. A colony facing an unexpected stellar flare or a biological crisis could not wait centuries for assistance. A wormhole gate makes every world a neighbor. Resources, expertise, and populations flow instantly, binding 1,000 star systems into what is functionally a single, interconnected planet. This solves the ancient dilemma of expansion versus cohesion. A civilization can spread to every promising world without fear of cultural or genetic drift, without the risk of forgotten outposts slowly failing in the silent dark. The gates become more than transportation, they become the arteries of a living, galaxy-spanning entity. The engineering challenges are, of course, titanic. It would require materials and energies that bend our understanding of physics, perhaps the controlled power of micro-black holes or the manipulation of cosmic strings. But for a culture that has mastered stellar lifting and vacuum energy, it is the next logical frontier. To build a wormhole gate is to declare that the universe's vastness will no longer be a barrier to community, to aid, or to shared destiny. It is the final act of turning a hostile, lonely cosmos into a place that feels, in every meaningful way, like home. The ultimate network of wormholes makes every star a neighbor, but the construction of that network demands resources on a scale that beggars belief. Where does a civilization find the raw material to build 1,000 gates, to maintain 1,000,000 bishop rings, and to extend its topopolises across the light years? The answer lies in a perspective shift so profound it redefines the meaning of home. This is the 19th megastructure, the Planetary Disassembly Framework. It is the ultimate act of cosmic recycling, the systematic taking apart of a world to build new ones. For a civilization that has spread across its solar system, the original planets are no longer the only homes, and some may not be homes at all. A barren, airless world like Mercury, or a cold, distant rock in the outer system, represents not a sanctuary, but a vast reservoir of raw materials locked away by gravity. The framework is a symphony of engineering on a planetary scale. It might begin with the construction of a network of orbital elevators, tethers reaching down from space to anchor on the surface, creating stable conduits for moving unimaginable masses. Alongside them, electromagnetic mass drivers like colossal railguns, would launch carefully packaged bundles of refined material on precise trajectories to construction sites in the asteroid belt or at Lagrange points. At the most advanced level, swarms of molecular disassemblers could methodically break rock down at the atomic level, sorting elements with perfect efficiency. The process would be slow, taking centuries or even millennia, layer by careful layer, from the crust down through the mantle. The sight would be both majestic and humbling, a world being gently unraveled, its substance transformed into a shimmering river of resources flowing into the void. To us, this seems like an act of profound destruction, the end of a world. But for a post-scarcity civilization that views matter as a tool for creation, it is simply the next logical step. It represents a utilitarian yet deeply respectful view of celestial bodies. A rocky planet becomes a quarry. A gas giant's atmosphere becomes a source of hydrogen and helium. These are not acts of vandalism, but of purposeful transformation, repurposing inert matter into the living, breathing structures that will house trillions for eons to come. It demonstrates that for a truly advanced culture, the sacred is not found in the unchanging rock, but in the enduring light of consciousness that those rocks are reshaped to protect. The framework completes the cycle of a stellar civilization, closing the loop between consumption and creation, ensuring that nothing in its celestial backyard goes to waste. But this mastery over matter and space leads to one final, haunting question. Once you can build anything and connect everything, what is the ultimate project worthy of a civilization that has conquered its own galaxy? The ultimate contingency plan is not a shelter but a seed. After mastering a galaxy, a civilization faces its final, longest-term threat, the end of the galaxy itself. Billions of years from now, our own Milky Way is destined to collide and merge with the Andromeda Galaxy, a slow-motion cataclysm that will churn stars like pebbles in a tide. While individual stars may not often collide, the gravitational chaos will fling countless systems into the dark void or send them careening into new, dangerous regions. For a culture that has built ringworlds and stellar engines, this presents a deadline written in the motion of the cosmos itself. The 20th and final megastructure on our list is the answer to that deadline. It is the Cosmic Ark, an intergalactic generation ship of unimaginable scope. This is not a single vessel, but a traveling fragment of a civilization, a self-contained artificial star system embarking on a voyage that will last for eons. At its heart could be a compact, long-lived star, perhaps a red dwarf, or even an artificial fusion source, surrounded by its own miniature Dyson Swarm to provide energy for the journey. Around this central power, a cluster of habitats, bishop rings, Topopolis segments, and Planetary Scale enclosures would travel together, a convoy of worlds. They would carry a complete, balanced biosphere with every necessary plant and animal, vast libraries holding the totality of the civilization's knowledge, and a genetically diverse population large enough to sustain a thriving culture indefinitely. The propulsion is the work of millennia, perhaps using the gentle, constant push of a Kardashev thruster on its internal star, or banks of vacuum energy harvesters. The journey's goal is a new galaxy, perhaps a younger, quieter spiral far from the chaotic mergers of the local group. The purpose of the Cosmic Ark is not exploration, but preservation. It is the final backup, the last copy of a civilization's essence sent into the deepest night. It accepts that some cosmic events are too vast to deflect, and that true survival sometimes means knowing when to leave, carrying your story with you into an even greater unknown. This arc represents the most profound form of hope, a belief that life and memory are worth safeguarding across not just millions, but billions of years of silent travel. It is the ultimate act of legacy, ensuring that even if the home galaxy fades into a new, chaotic shape, a spark of what was once built there continues to glow, a tiny, deliberate light moving with infinite patience through the endless dark between islands of stars. From planetary shields to cosmic arcs, these 20 blueprints form a single, breathtaking narrative. They chart a civilization's journey from protecting its cradle to preserving its legacy across the emptiness between galaxies. Each structure is a response to a specific threat, a solution forged in the fires of necessity and projected across timelines that dwarf human history. They are not idle fantasies but logical extensions of the most fundamental drive we know, the will to survive, scaled up to match the grandeur and the peril of the cosmos itself. For us, these concepts exist in the realm of distant speculation. The engineering challenges are so far beyond our current capabilities that they feel less like plans and more like mythology written in the language of physics. Yet, that is precisely their value. Contemplating them does something essential. It stretches the canvas of our imagination. It forces us to think not in fiscal years or political cycles, but in geological epochs and galactic rotations. It asks what a culture becomes when its planning horizon extends 1 billion years into the future. This long-term perspective is perhaps the most important takeaway. It reframes our current technological struggles not as ends, but as the very first clumsy steps toward a much grander form of stewardship. Every solar panel we refine, every asteroid we map, every effort to sustainably manage our own planet's climate is a micro-practice for the macro-engineering that may one day define our species. These megastructures serve as celestial landmarks on a map of potential futures, reminding us that our ambition can, and perhaps must, grow to meet the scale of the universe we inhabit. They inspire a simple, profound question. What small step could we take today that points toward that distant horizon? Your perspective is a vital part of this conversation. Looking over this architectural catalogue of cosmic ambition, which structure resonates most with you? Do you see humanity's first great project being a humble planetary defense grid, a practical bishop ring, or something else entirely? Share your vision in the comments below. If journeys to the farthest edges of science and imagination captivate you, consider subscribing for more. The future is a story we are all writing, one idea at a time.